Let's look at some vector subtraction. This is page 105 in the book. All right, you can just watch if you want. You can copy. You can print out later. Whatever, your choice. Let's talk about vector subtraction. When we did components by vector addition, addition by vector components, right? Basically, the steps are to find the x and y components, right, of all the vectors, and then do what? You find all the x and y components, then you add all the x, add all the y, and then do Pythagoras at the end, right? Combine the x and y components together. So vector subtraction is practically the same as vector addition, with the only real difference being you subtract the components. Let me show you an example, okay? We know that, you might remember from grade 11, we might know that the resultant is plane plus wind, right? If we've got a plane vector and a wind vector, and you're having to find out the overall resultant, right? The overall resultant is whatever the plane's speed is plus the wind speed, right? And the plus sign simply indicates that we should place those vectors tip to tail. Okay? So if I've got a plane which is headed straight north, and I've got the wind which is blowing due east, I end up going northeast, right? That's pretty straightforward, pretty basic.
It's pretty angled, actually. The wind carried it
Okay.
to the east.
Now if I rearrange my vector problem, my vector addition here for P, you can see that if I took W to the other side, I would have plane vector is equal to resultant minus wind, or if you were solving for the wind, it would be resultant minus plane. And you might remember how much you hated vector subtraction from grade 11.
Yeah, the protractors and junk.
Yes. Okay? So this means vector subtraction if it asks you for the wind speed or the plane speed, right? Not the overall result. If you need to know what direction the plane should have had, or what speed the plane should go, or if it asks you for the wind speed, you're going to be doing vector subtraction because of this concept here. Okay, I'll pause there for a second. So let's look at sort of a specific example here. Okay? To subtract vectors by components, you really just subtract rather than add the components. Rather than taking ax plus bx, you just ax minus bx. Subtract the components. That's as simple as it is. Really. Okay? So here's a completely arbitrary, made up, doesn't mean anything kind of problem. You've got vector A is 12 at east 26 south, and vector B is at 8 east 14 north. And for some reason, you've been asked to subtract these vectors. Okay, we won't get into the y part, we'll just do the actual math part.
So A is, so east 26.
Okay, here we go. So we've got A is 12 at east 26 south, B is 8 at east 14 north. Simply find the components once again, just like we did in vector addition. So A is east 26 south, so east and south. When the vector is written like this, it's easy to figure out which way it is because it's east and south, right? So 12 at east and then south. This is 26 degrees up here. This is AX, this is AY.
Wait, so where did you get, so 12 is already a known factor?
Yes, this is what I'm giving you. And I'm asking you to subtract them. Right? So it's going to be, this is cosine, so this is going to be 12 cos 26, and the AY is going to be 12 sine 26. And do I have answers for those? No, I don't. Okay. 10.8 and 5.3. Now the x is to the right, so it's positive, but the y is down, so it's negative. Is that important?
Yep.
Oh yes.
No.
Oh yes.
Very.
Is that 5.3 or 5 times 3?
5.3 minus 5.3. Now we simply do the same thing with the b's. So it's east 14 north, so east, north, it's 8. So it's going to be 8 cos 14 and 8 sine 14. But I don't have a calculator, so I'm going to ask Brett to do it because today's his last day.
That's big.
7.8?
He hates you, John, he could stand you, so he's.
1.4.
Nice for Lindsay.
No.
Yeah,
Why
you
do you want to put
want
someone else's name in front just to express your opinion? Because it's 935.
Okay. One is to the right, the other one is up, so they're both positive. This is just what I showed you last week, finding the components, right? Nothing different here. If you were to add them, you would take 10.8 plus 7.8 and minus 5.3 and 1.94. Just add the components. But it's not. It's subtraction. So we subtract them. Cx is equal to ax minus bx, so it's going to be 10.8. Right? Minus 7.8, which is 3. And ay, which is minus 5.3, and we subtract 1.94, which is going to be like 7.2 something. What is it?
Negative 7.24.
negative 5, 7 point.
Okay, so all I did there was simply subtract the numbers,
Yes.
right? Now I have to create my Pythagoras triangle, which I
It's the exact same thing except with negative 3 squared.
which I didn't finish for some silly reason here. So it's going to be, now the x is 3, so it's going to be this way. Then the y is down, so that's going to be 3, and this is not to scale at all. Well, it should be reasonable. Right, so this is going to be my c. C squared is going to be 3 squared plus 7.24 squared. 7 point
Oh,
what?
you don't have to do the negative, do you?
No, you can if you want, but I mean, it doesn't make any difference. 7.84, and then you just find the angle. Really, like vector subtraction, what one thing did you have to do different?
Subtract.
Subtract. Ooh.
I wonder what they call subtraction.
Now, could you have, if you stop and you think about it, could we have done, because remember what I said when we did vector subtraction in grade 11, was that I said you had to change the direction, right? So this would be west 14 south, right? All that would change down here would be, instead of this way, it would be that way, right? And your x would be to the left, so that would be negative. And your y would be down, so that would be negative. And then you would just go 10.8 plus a minus 7.8, the same thing. And you'd go minus 5.3 plus minus 1.94. That's what we did.
I think it's 7.4.
Okay, so why did you, wait, well, why did you have to go back and change it?
I didn't. I'm just saying, if you chose to do it, I'm reminding you about in grade 11 when I said change the direction, right? Changing the direction would point it this way. That would make these guys negatives here, and then you would add them, but you're adding a negative would be just like subtracting, right? It's the same concept. So you don't have to switch the direction, is what I'm saying.
Oh, okay, gotcha.
You don't have
Yeah,
to.
because you would make it switch directions, so we always add.
When you're subtracting, you are basically switching the directions, right? Yeah.
So time.
Okay. So there's a few problems in the book there that you can practice with. Those two hand-ins that I gave you, there was 2 kinematics problems, and there are 1 vector addition question there, okay? If you could get those to me by,
Alex, I'm
Can we
moving.
say like next week, just so that I can build my cheat sheet?
Moving your house.
well, I'm just thinking if you get them to me prior to the test, I can get them back to you.
Hey, well, you think I'm busy watching concerts or something?
Which better? On this one with the trick?